Hello, and welcome to Nearmap NAVIG8 2022. My name is Staton, and I'm the Director of Solution Engineering in North America here at Nearmap. And I have the pleasure of presenting with Kevin Tulp, who is our Senior Solutions Engineer for Insurance.
Greetings, navigators, and welcome to our workshop.
Together, we want to present and demonstrate how to call the AI Feature API, ingest Nearmap AI vectors inside of ArcGIS Pro, and combine them with high-resolution imagery and 3D datasets to give intelligent location insights. You will also learn to create derivative products, including level of detail 2 buildings, and add attributed information for each structure to aid in the process of frequently updated property information. I will now hand it over to Kevin to talk about our AI Feature API for a dataset in Pleasanton, California.
We've really been looking forward to this session, so let's get started. A few of the tools I'll be using today are ArcGIS Pro, PyCharm, which is a Python SDE environment, and the parcel dataset is from Pleasanton, California. So first up, I have the parcel dataset loaded into ArcGIS Pro. I'll be leveraging only one geoprocessing tool to convert this into a GeoJSON. So I have the input features as a parcel dataset. I have the output going to a desired folder location. Make sure to have the output set to GeoJSON. I'm going to run this. Just a couple seconds to get it done. Now let's open up our Python SDE environment. So now that we have PyCharm open, I want to talk first of a few things that we're looking at here. This is our AI Feature API that we've wrapped in Python for a variety of reasons. This is a language that I'm comfortable to use, and a lot of geospatial professionals are as well. These are the same parameters that you would see on our docs page for our AI Feature API. I have the parcel directory, so that's that parcel dataset we just made, already set. The output directory going to a different location. Those are the only two parameters I'll be leveraging today, but I wanted to talk about a few of the others and their ability. In particular, the since and until, where you can temporally query the data to pull from certain dates if that's what your desired outcome was. So let's go ahead and run this. This should take a couple minutes. I'm going to go ahead and shoot this back over to Charty to take over the second portion of the workshop.
Thanks, Kevin. I will now download the geo package and save it to an appropriate location on my machine. I'm going to extract it and put it into my geo database. Next, I'm going to convert the geo package to a geo database, because it works more seamlessly inside of ArcGIS Pro. So now I have my database features, and I'm going to simply add them to my map. Next, I'm going to leverage Nearmap imagery as my base map from the Esri marketplace. To do that, our gold level partnership enables us to have an ArcGIS marketplace item on the Esri marketplace. This is a tiled service that can be consumed in any ArcGIS application. Simply adding data, connecting to ArcGIS Online, and searching for Nearmap US vertical imagery will bring you to the marketplace item authored by Nearmap_engineering. Once you've added that to the map, you now have high-resolution imagery behind your AI datasets. One last step I'm going to do is leverage this marketplace item's ability to travel through time. Under the Properties tab for Nearmap US vertical imagery, I'm going to select the Time field. Under Layer Properties and Time, I'll select the layer time where each feature has a start and end time. The time extent is going to be in 2014, when Nearmap first started flying in the United States. The end time will be today, so that we can capture the largest breadth of imagery available. Once I have that, a toolbar will be enabled for me to shift through different dates and select the appropriate date of the imagery from which the AI features were extracted. These datasets enable us to gain intelligent insights for buildings and other surface features for a neighborhood, city, or project. Our AI adds attributes like building height, square footage, and surface area, and also enable the addition of known user data to increase your data integrity as well as add to your system of record. Here are the AI attributes. Now I'm going to take this to the next level and bridge the content gap between 2D and 3D by creating level of detail 2 or LOD2 buildings using Nearmap AI and 3D data. The first step I'm going to do is create a normalized digital surface model, or NDSM. So I have my digital surface model as well as a digital elevation model to do this math. Under the Imagery tab in ArcGIS Pro, I'm going to select raster functions. Within raster functions, I'm able to select the Math tab and choose the minus tool. This minus tool is going to enable us to subtract the digital elevation model from our digital surface model and create an NDSM. Under the General tab, for our output pixel type, we'll choose 32-bit float and create this new layer. The result is an elevation raster that represents the ground level elevations of features as well as their height. Next, I'm going to be using the Esri 3D base map solution to create some buildings. Under the Task tab, How to use 3D base maps, there's going to be a folder that we'll concentrate on today. This will be Publish Buildings. Under Publish Buildings, I will go to the step Pre-process Building Footprints. I'll skip to the next step, which segments building footprints using elevation. Our building footprints will be the footprints that Kevin called using the Nearmap AI feature API. The elevation surface will be our digital surface model, spectral and spatial detail to remain at 13, and we'll change the regularization tolerance to 2 meters. We'll run this tool and receive the output of building footprints that have been segmented using elevation. That looks great. Now that I've segmented the building footprints, I'm going to extract the roof form information to create level of detail 2 buildings. This tool will automatically extract roof form information such as base elevation, eave height, eave building height, roof form, as well as roof direction. So under the 3D Base Maps tool, I'm going to select Create Buildings. For the buildings, we're going to use the segmented footprints that we just created. We'll use the digital surface model and the digital elevation model as our ground. For the normalized elevation surface, we'll use the NDSM that we created previously and change these to Pleasanton Buildings. This task can take several minutes up to an hour to run, depending on the size of your data set. Once this tool has been completed, you will receive an output that is representative of each building and structure, as well as the roofs. Now that I've created my vectorized containers, I'm able to see the remaining attributed information from the Nearmap AI. I'm also able to keep tabs on my built environment as well as add data for each individual building. This greatly aids in communities and organizations to document change over time. All of this is possible using Nearmap content inside of ArcGIS Pro. We hope you learned something today. Thank you and have a great rest of your conference.